This is February the 4th that this was published. And it is describing the medications, specifically remdesivir and chloroquine, and why this is important. So let's talk about remdesivir first. Going back, there were a number of medications that were looked at during the SARS and MERS outbreak, both of which, by the way, are coronaviruses. There were medications that they had tried, like ribavirin. Obviously, they had tried remdesivir as well. And these were shown to be efficacious in stopping viral production in vitro. So the key there is the word in vitro. In vitro means in a petri dish, in a test tube, not necessarily in a human being. And this is where a lot of tests are done at first. Now, what they did do is they looked at this medication called remdesivir, and they tried it in Ebola. And the reason why they did this was because it worked in Ebola. It worked in vitro in Ebola. And they said, hey, maybe we can try this in Ebola patients or in people who are in proximity to people with the Ebola virus so that they don't get Ebola. And so when they tried it, it didn't work. Okay, people still got Ebola. So that's an example where a medication works in vitro but not in vivo. Nevertheless, before they could take this medication, remdesivir, to market, before they could even try it in these patients, they had to make sure that it was safe. And so the safety tests have already been done on remdesivir. We know that it's a relatively safe medication to use in patients. The problem was it just didn't work in vivo, in patients in real life. But it did work in vitro against a bunch of viruses. So enter in now the coronavirus 2019, and you've got a situation where people are dying and there's an epidemic. Why not try remdesivir? Well, the first thing you've got to want to do is to make sure this medication actually works against not the SARS, not the MERS, not Ebola, but the actual coronavirus 2019. And so that's what they did. They actually tried it in cells that were infected with the current strain of the coronavirus from Wuhan, China. Now, how does this medication work? What does it do? So you've got the cell and you've got the virus, and the virus has to fuse with the cell and it goes inside the cell. And when it does that, it basically dumps its RNA into the cell and uses the cellular machinery to reproduce more RNA. Well, for those of you who are aware of what RNA is, or DNA for that matter, it's basically just a code. And you know, the DNA code, for instance, is like A, T, G, C, and this can go on and on and on. With, however, RNA, instead of having the T's, those T's become U's. So instead of T's, you'd have AU, GC, UU, okay? That's the only real difference, and of course, it's usually single-stranded, and DNA is usually double-stranded. So what happens is that these nucleotides are lined up one after the other, and there are, tRNAs that come in and help put the nucleotides in the correct order, and this is done using different polymerases. Well, what this medication does is it resembles one of the A's, except it doesn't allow the next one to come on, whatever that happens to be. So the virus comes into the cell and it says, aha, I'm taking you over, and you're going to start to produce more RNA viruses like me. And so the machinery starts to go along, and as soon as it gets to an A, this medication gets put in, and boom, it's done. There's no more polymerization. The strand cannot continue, and so this arrests the production of virus. Well, the good news is that they found that this worked well in the new 2019 strain of the coronavirus. And so here you've got a medication that has already been tested on human beings for safety. It's available. It's there. You just don't have a good FDA indication because it doesn't work on Ebola, and you don't have a SARS outbreak currently, but now you've got this coronavirus outbreak. So what do? Even though they don't have any evidence that it's going to work, and usually we only give medications to people when we have evidence that it works, they use it for something called compassionate use. In other words, look, this patient's going to die. Let's give them this medication, see if it works. So they did that. They did that in the first patient in the United States that came down with the virus, and it was in Washington State. And within a day, This patient started feeling better, and within 3 or 4 days, the fever completely went away. And we've got a number of articles that talk about this, and we'll put those in the links. So this could be a big breakthrough here if this works. But remember, want to make sure that you understand that this medication has never worked in vivo. So we don't know if it's going to work. So what they're planning on doing here coming up very shortly is they're actually going to undergo a trial in China where they give some people placebo and they give others this remdesivir and see whether or not it works. We should know by the end of April whether or not this thing is going to work. Now, as you can imagine, this has caused some stir. The company is Gilead that makes this, and I'm sure if you look at their stock prices, they're probably going up in the hopes that this thing works and that the epidemic can be abated. So the other drug that they looked at in the same letter to the editor in that study was chloroquine. Now, chloroquine has been around for a very long time. It's a generic medication. It's been used in malaria for years. In fact, so much so that you actually have chloroquine-resistant areas. They also found that this worked really well as well. So how does that work? Well, you've got the cell, you've got the virus. There's a